Now another important numerical, and it is must for your JEE Main. Before I proceed, I must explain you what is potential and potential difference, then I will proceed. Now, so let us first have a clear concept of that. When you go to a shop or market to buy a pencil cell for your TV remote or your air conditioner, you get a battery like this. It will be written 1.5 volts, a plus side, minus side. What is the meaning of this? The potential difference between these 2 points is 1.5 volt. This is represented like this in a circuit. Negative, positive, the potential difference between this point and this point is 1.5 volt. Means if you take this side at 0 volt, then this side is at 1.5 volts. So the difference is this minus this, 1.5 minus 0, that is 1.5 volt. Suppose in some example, it is shown like this, 30 volts battery, means the potential difference between this point and this point is 30 volt. Means if this is at 0 volt, this side is at 0 volt, then this side is at 30 volts. Or you can say, if this side is at 5 volt, then this side is at 35 volts. So this minus this is equal to 30 volt. But in general practice, you do it like this. Suppose it is written 30 volt. So you take this side as a 0 volt. That is as if it is connected to the earth, because this is the symbol for connecting to the earth, which is at 0 volt. And therefore this side is at potential of 30 volts, right? So this you connect as if it is connected to earth, that is at 0 volt. So obviously this side is at 30 volts, so 30 minus 0 is equal to 30 volt. That is same thing as this. Now let us go back to the problem. Very simple. Now 4 capacitors with capacitances C1 1 microfarad, this is 1 microfarad, C2 this one 1.5 microfarad, C3 2.5 microfarad, and C4 0.0 microfarad are connected as shown to a 30 volt source. What is the potential difference between the points A, small a and small b? This point is small a, this point is small b. What is the potential difference between these 2 points? Very simple. Now look, from here to here, this capacitor and this capacitor are in series in the same line. So the charge in C1 will be the charge in C2, and these two are also in a single line. So therefore these two are also in series. So the charge in C3 and the charge in C4 will be same. So C1, C2 are in series, and across the combination of C1, the potential difference is 30 volts. Look, this point A is same thing as this point A. This is also A, this is also A, this is also A, this is also A, this is also A. This point is same. So the point A is at 30 volt. Similarly, the point B is here, that is same thing as 0 volt. So 30 minus 0 is the 30 volt, right? Now, if you look at these two, C1 and C2, which are in series, the combination of C1 and C2, they are connected between this point and this point. Means across the combination of C1 and C2, the potential difference is 30 volt. Again, C3, C4 are also in series. This side is connected to here and this side is connected to here. So the combination of C and 3 have a potential difference of 30 volt across it. Again, C3, C4 are connected in series, and across the combination of C3 and C4, the potential difference is also 30 volts, right? Now, whatever charge flows from here, it will be distributed to this side, it will be distributed to this side. let to this side is equal to Q1, to this side is equal to Q2. So now analyze. Let Q1 is equal to charge in capacitor C1 and C2, because they are in series, they will have the same charge. And we know Q is equal to CV. From this, V is equal to Q over C. So V is equal to Q over C. Now look, across this, V will be the Q of this divided by its C. The Q of this is Q1 divided by its capacitance, that is equal to 1. Now, so this is the potential across this capacitor. Means if you connect a voltmeter, one end here and the other end here, you will get this reading, Q1 by 1, because charge by capacitance is equal to a potential. Similarly, the potential across this capacitor, if you connect a voltmeter, one side here and one side here, then it will be Q1 by 1.5, because Q by capacitance, its capacitance is 1.5, is voltage. Now this voltage plus this voltage is nothing but, the voltage across this plus voltage across this is the total voltage across this. That is same thing as a 30 volt. So Q1 by 1 plus Q1 by 1.5 is 30. I take Q1 common, I am left with 1 plus 1 by 1.5, 30. So I get Q1 is equal to 18 microcoulomb. Because this was given in microfarad, so the charge will be in microcoulomb. Now similarly, Q2 is the charge in this capacitor as well as in this capacitor. So across this, the potential will be the charge in it divided by its capacitance, and across this the potential will be the charge in it, that is same Q2 divided by its capacitance. So if you connect a voltmeter, one end here, the other end here, you will get a reading Q2 by 2.5, because charge by capacitance is potential. Similarly, if you connect a voltmeter, one end here and other end here, you will get a reading of Q2 by 0.5, because charge by capacitance, Q by C is volt. Voltage plus voltage is equal to 30 volt. How this is 30? If you look at this as well as this is connected here and this is connected here, so that is 30 volt. So the potential drop here and the potential drop here, the sum of that is 30. So your second equation is taking Q2 common from here, I am left to it 1 by 2.5 plus 1 by 0.5, that is equal to 30. So cross multiplying, Q2 is equal to 12.5 microcoulomb. Now we don't know the potential of this point, as I just explained you. If you are given like this, it is written 30 volt. If this side is at 30 volt potential, then this side at 0. So the difference is 30 minus 0 is 30. If this side is at 5 volt and this side at 35 volt, then 35 minus 5 is also 30 volt. So now we don't know the potential at small a and small b. Let V small a is the potential at the point small a, V small b is the potential at small b, V capital A is the potential at A. That is same thing as 30 volt. We will not use this. We will just use this. Look how this point is same thing as this point. All these points are at the same potential, 30 volt. So charge is flowing from this side to this side. So this side is at higher potential, this side is at lower potential. So V capital A minus V small a. So V capital A minus V small a is the potential difference across this capacitor, and potential difference will be V will be equal to charge flowing through the capacitor divided by its capacitance. So for this one VA minus V small a is the potential difference, that is equal to charge flowing through, that is Q1 divided by its capacitance. Q1 is 18 microcoulomb, that we just found out here. Q1 is 18 microcoulomb. So Q1 over C1, 18 microcoulomb, C1 is given as this cancels. Coulomb over farad is nothing but volt, because we know Q is equal to CV, so V is equal to Q by C. The unit of Q is coulomb, the unit of, so V is equal to Q by C. The unit of Q is coulomb, unit of capacitance is farad. So coulomb over farad will be the unit of potential, that is volt, so 18 volt. So V capital A minus V small is 18 volt. Similarly, this side is flowing Q2. This point, this point, this point, this point, all these points are the same point A, that is at 30 volt. So potential at capital A minus potential at small b is the potential difference between this capacitor. So V capital A minus V small b is the potential difference across this capacitor, and potential difference will be equal to your charge over capacitance. The charge flowing through this we have found out, that is 12.5 microcoulomb. So that will be, so V capital A minus V small b is equal to charge over its capacitance, 12.5 by 2.5, this cancels, so 5 volt. So we have one equation here, one equation here. Let us subtract this equation 2 from equation 1, means this minus this this minus this will be 18 minus 5. So that is what I have written here. V capital A minus V small a, that is this, minus of this, that is V capital A minus of minus plus V small b is equal to 18 minus 5, that is equal to 13. So your VA cancels. So we are left with V minus VA is equal to 13 volts. So the potential difference between these 2 points is 13 volt. Or you can say, from this you can say V small a minus V small b will be minus 13 volts. Fine.